All right, we're picking up where we left off with our 6.4 notes. What type of shape is this? A rectangle. We know that because they told it to us. Because we know that it's a rectangle, we can use the properties of a rectangle to talk about these measurements. So, the measurement of angle 1, how are we going to find that? Close. You got the right idea. 90 minus 21. Okay, so we know that if this is a rectangle, that is a right angle. So to find the measure of angle 1, we're going to take 90 minus 21 degrees. What do we get? 69. So the measure of angle 1 is 69 degrees. Okay. Which angle do we want to find next? 2? Okay. How are we going to find angle 2? How do we think we're going to find 2? So we know this one in here is 69 degrees. So this one's going to be a little tricky. So what do we know about the diagonals of a rectangle? They bisect each other. What else? They're congruent. So if they bisect each other and they're congruent, then all of these pieces are equal. Does that make sense? All these pieces are equal. Which means if we look at just this one triangle, I'll try to highlight it. Just this one triangle here. What type of triangle is that if two sides are congruent? It's an isosceles triangle. What is true about the angles across from the congruent sides of an isosceles triangle? They're congruent, which means that this angle 1 is congruent to which angle? Angle 2. So those two angles are congruent, which means angle 2 is also going to measure 69 degrees. Questions about how that works? Okay. Which angle would you like to find next? Number 4 would be the most challenging angle to find. We need to find either 3 or 5 before we go for 4. Okay, let's go with 3. I'm going to erase some of this just to clear this up a little bit. Very good. If this is all inside one triangle, we can take 180 minus both of those 69s to get the last angle. What do we get?
42.
42. We agree with 42? 42 degrees there. Okay, if angle 3 is 42 degrees, how can we find the measure of angle 4? If I know the measure of angle 3, how could I find the measure of angle 4? Perfect. Why can we do that? I love that explanation. 3 and 4 make a straight line, and a straight line is 180 degrees. So 3 and 4 together should add up to 180. What does 4 have to be? 130. Kiatha? Okay. 3 and 4 together make up a straight line, that diagonal that goes down the middle. We can highlight that straight line. Together, 3 and 4 make up the angles of that line right there in the middle. If two angles are a linear pair, or they make a straight line, then they have to add up to 180 degrees. So we took 180 minus the 42 to get the 138. Our last angle that we need to find is going to be angle 5. There are a couple different ways we could go about figuring out what angle 5 is. What's one of them?
Can you just do the opposite point? Well, it should be 69.
It will not be 69.
21.
Why would it be 21?
Because it's opposite H or whatever that is. Opposite to 21.
I think you're on the right track.
Plus 21.
So what type of triangle is this?
Isosceles, that makes sense. Yep, you're correct.
We have an isosceles triangle again. This time it's just a different isosceles triangle, which means that the angle down here at H, the 21-degree angle, and angle 5 have to be congruent because they are across from the congruent sides of that isosceles triangle. So even though we're learning about quadrilaterals, we still have to know all of our properties and special things about triangles too. Any other questions about anything on example 4? Are we ready for example 5? We do have a lot to find on number 5. I'm going to recommend we start with things like AB. What would AB be? 12. Why?
Because BC.
What type of shape is this? A square, which means all of our sides are congruent. So what other ones are 12? AB is 12. What else? AD is 12. I don't think they put AD on there, but it is. What else?
What is BX?
DC and BC. Okay, so that's the other one on our list. Okay, so we know that these are 12s all the way around. Next, we need to start looking at our diagonals. So I would recommend looking at the big diagonals first.
You talking about like BD?
I am talking about BD and AC. I think those will be easier to find first. So let's just, to make this a little clearer about how we find this, let's look at AC first. So I'm going to take away that part of our square so we can focus just on this triangle. Now what kind of angle do I have down here?
Right.
I've got a right angle down here. So what type of triangle is this? Do we remember? It's more specific than that.
Right isosceles triangle.
It is a right isosceles.
You want more than that?
I do. It's a special right triangle. I would go back to your notes from yesterday.
A 69,
It's not a 30, 60, 90.
45, 45, 90.
It's a 45, 45, 90.
Oh.
Okay. If we have a 45, 45, 90, and we're looking for the hypotenuse, we're looking for the side across from the right angle, we take one of the legs and we multiply it by,
Radical 3.
not radical 3,
Radical.
radical 2. So what's the length of one of my legs?
12.
12, and I'm multiplying that by radical 2, and that's going to give me my diagonal AC.
why did I just do that to begin with? Why did I look for 45, 45?
Yes, so DB is our other diagonal. It also has a length of 12 root 2. So I'm going to bring back our original diagram. Okay. We okay with how we found the diagonals? Now we're looking at pieces of them. All right, now we're left with dx AX, and BX. Anybody know what's nice about the fact that those are the three that are left?
They all equal.
They're all the same. Okay, so if a square is a version of a rectangle, then its properties hold. So all of these pieces of the diagonals are congruent to each other.
Right.
So you just have to find one of them. What else is true about the diagonals? Like if you just think about one diagonal. What's that special word that begins with a B? Bisect. They bisect each other. Split it in half. So if I know the whole length, how can I split that in half?
Divided by 2.
Divide by 2. So dx would have a length of
2.
6 radical 2.
Boom.
And that means that AX has a length of 6 radical 2. And BX, they're all the same. Are we okay with all the segments before we move on to the angles? All right, the first angle they ask for is angle AXB. Now, I feel like part of the challenge here for some of you is going to be figuring out where that angle even exists. So somebody tell me directionally. Is it like a top left, bottom right, in the middle?
AXB is the top triangle.
It's in the middle. Yes, it is part of the top triangle, but it's in the middle. AXB.
Where the X is.
If you start at A, and then trace a line to X, and then trace the line to B, that's that angle that we're talking about. It seems that some people still have a difficult time dealing with angles with 3 letters. All right. Because a square is a version of a rhombus, what's true about the diagonals? What? Why is there a 90-degree angle there? What's part of the property of a rhombus? Perpendicular. The diagonals are perpendicular, making this a right angle. So AXB is a 90-degree angle.
That's our answer, right?
No.
The next one that we're talking about is XAB. So this time we're starting at X, drawing a line to A, and then going over to B. Now we kind of talked about what that degree measure should be earlier. Julian? That's going to be a 45-degree angle.
Ow.
Inside of a rhombus, the diagonals bisect the angles. So because a square is a version of a rhombus, it's going to split that 90-degree angle into 2 45s. The next one's also 45. This time we're looking at XBA, which again, the diagonals split those angles, so it's also 45 degrees. So that wraps up our 6-4 examples.